Hi boys and girls, today we're going to work on notes for 2.1, finding parts of parts. Last week we added and subtracted fractions. We estimated the location of fractions between benchmark numbers. Today we're going to continue with that, but now we're going to move on to multiplication. But before we begin, I wanted to address that last problem in 1.4. I was okay here. No issues. This was okay. It's when I started solving this problem. Yes, don't forget to write the problems. All right, this is where I'll stop. So this is how you correctly do this problem. This is where I need to correct a mistake. That's the original problem. This is correctly how to answer the problem. If you have an unknown as part of a subtraction problem, you need to isolate n, move what you know together on the other side. You're not going to change the operation. I did that over there. You're not supposed to change the operation. And then you subtract. You change the denominators so that they are common. In this case, it's 12. The numerators are 8 and 3. You get 2 minus 1, which is 1, and 8 minus 3 is 5/12. This is the correct answer. But I gave you something different. All of these answers were 1 and 5/12. For E1, over there on that side, 3 and 1/6 minus 1 and 3/4 equals n. N's already isolated, so all you have to do is complete the operation and subtract. However, 2/12 is less than 9/12. If you remember from 4th or 5th grade, you subtract the numerators, and you do it in order from left to right. But in this case, you can't subtract 9 from a smaller number of 2. So you have to borrow from the 3. And since 12/12 equals 1, you take that from the 3 and you add it to 2/12. Then you get 2 and 14/12. And then you can subtract 1 and 9/12 to equal n, and n equals 5/12. This answer for E2, the n is isolated in the addition problem. So n plus 3/4 equals 1.5. So what you have to do is isolate the n by moving the 3/4 up to the other side and subtract it to 1.5. So you get this. But then what I did this time was change the mixed number into an improper fraction. So 1.5 equals 3/2 minus 3/4. And I convert the 3/2 into a fourths with a 6 as a numerator, so that these two are common. And now I can subtract 3 from 6, and the answer is actually 3/4. And that's the answers for last week's notes. No, you do not have to copy these notes down. So thank you, those of you who brought it to my attention. Okay, boys and girls, now you're going to start taking notes. Pause here if you need to make a couple of pages of notes. I think we'll need about 2 pages. I made 3 just in case. Go ahead and pause here and set up your paper. All right, now we're moving on to the multiplication of fractions. Sometimes instead of adding or subtracting numbers, you need to multiply them. For example, suppose you take inventory at a sports drugstore. There are 13 full boxes and 1/2 box of footballs in the storeroom. 12 footballs fit in each box. How can you find the total number of footballs without opening the boxes? Why does multiplication make sense in this situation? In this investigation, you will use multiplication to solve problems involving fractions. Remember, to make sense of a situation, you can draw a model or change a fraction to an equation form. You can also estimate to see if your answer makes sense. So boys and girls, in this section, we're going to find parts of parts by using what you already know of multiplying fractions and explaining it and applying it to a real world situation. That's what we do in 6th grade. We take what you know already and we build on it and apply it to real life. And that's what we're going to do with multiplying fractions. Why do we multiply fractions? So this is titled 2.1, How Much of a Pan Have We Sold? Finding Parts of Parts. Paulo and Shania work at the brownie booth at the school fair. Sometimes they have to find a fractional part of another fraction. For example, a customer might ask to purchase 1/3 of the brownies in a pan that's 2/3 full. So how much is 1/3 of 2/3? So that's an example of a real world situation multiplying 2 fractions. But today we're going to learn how to understand how to read the multiplication problem. Instead of saying 1/3 times 2/3, it's 1/3 of 2/3. And then you can visualize it, 1/3 of 2/3. So you have part and whole. 2/3 is the whole pan right here that's left, and you want 1/3 of that part. So part of a whole. Here's our first problem. All of the pans of brownies are square. A pan of brownies costs $12. You can buy any fractional part of a pan of brownies and pay that fraction of $12. For example, half of a pan cost half of $12 or $6. And you could write this as a number sentence using of. So half of 12 equals 6. Okay, here's A1. A1 says use a copy of the brownie pan model shown at the right. Draw a picture to show how the brownie pan might look before Mr. Williams buys his brownies. And the problem for 1, 2, and 3 is here. A. Mr. Williams asked to buy half of a pan of brownies that's 2/3 full. For the first part, we need to address what he starts off with. He's looking at 2/3 of a brownie pan, and he wants to buy half of that. All right, draw your model. Let's look at A2. On the same model, use a different color to show the part of the brownies that Mr. Williams buys. Note that Mr. Williams buys part of the brownie pan. So here's a part of the brownie pan, and it's 2/3 full. Mr. Williams wants to buy half of this. There are two ways to do it. Think about it. I'm going to use tape because I want to show how which parts he could take. He can either take half, he can either take this part, or Mr. Williams can take this part. It's not exactly half, but he can take a horizontal slice or vertical slice this way. Either way, it's half of 2/3 of the whole pan. So he has one whole, but someone bought 1/3 of the pan. So he says, okay, let me have half. So he can either have half going vertically up and down, or half going from left to right or horizontally this way. Okay, here are two different ways Mr. Williams can choose to buy half of the 2/3 of the pan. He can either request for them to cut it this way, and he takes these two slices, or he can cut it this way and he'll get this slice. And if you put these two side by side, they should be equal. Let's move to A3. Don't forget, you do have to copy the problems and all the solutions. As I was grading some of the notes, I noticed that there were 3 students who copied the same notes, and I know that because it was images of someone else's notes. 3 of them are going to have 0 credit for that. That's called cheating. You need to process your own notes. Please don't have someone take notes and then get a copy of it. That's the same thing as cheating, and I know you know better than that. Take ownership of what you're learning and do your own work. What fraction of a whole pan of brownies does Mr. Williams buy? How much does he pay? And write a number sentence using of to show your thinking. When we're looking at the pan, we're looking at what fraction of the whole pan does Mr. Williams buy. So this is for Mr. Williams. These two are for Mr. Williams. And this one for Mr. Williams. Now we have to find out how much of the whole thing does he buy. There are 1, 2, 3, 4, 5, 6 equal pieces. 6. And of those 6, 2 of them are for Mr. Williams. We can also say that's 1/3 of a pan of brownies, because they want to know of the pan. So Mr. William buys 1/3 of a whole pan of the brownies. The question wasn't what fraction of what's left. They asked what fraction of the whole. So you have to divide it into equal pieces and then count what the whole is, 6. And Mr. Williams has 2 of the 6, and we can also simplify that to 1/3. If he did it this way, there are 3 equal parts of the whole, and Mr. William gets 1. And it's the same thing, they're equivalent. These are equivalent models, equivalent fractions. Mr. William buys 1/3 of the pan of brownies. Now, how much does he pay? We know that this whole thing is $12. So if there are 6 slices and it costs $12, how much is each slice? Or we can also say, what's 1/3 of $12? So there's 2 ways you can do this. You can either write how much each slice is. If it is $12 divided by 6 slices, each slice is $2. So 2, 2, 2, 2, 2, and 2. Or you can write 1/3 of $12 equals, now when you look at a bar model, if this is 12 and you divide it into thirds, we know that each third is equal 4. And 1/3 is $4. So $4. We can also say that each of these, if there are 3 slices, $12, and divide it into 3 slices, you get $4. Or you can say 1/3 of 12 equals $4. Here's my response for A3. Mr. William buys 2, 6, or 1/3 of a whole pan of brownies. He pays $4 because 1/3 of $12 is $4. I have to use the word of in my number sentence. If you see here, the word of, it tells us we have to use the word of. So a number sentence, this number sentence does not have the multiplication sign. It wants us to use the word of so that we can visualize what that number sentence means. 1/3 of a whole is $4. 1/3 of a whole is $4. Here's our next problem about Serena. Problem B, Serena buys 3/4 of another pan that is half full. So here's our pan of brownies that's half full. The other half has been sold. Draw a picture to show how the brownie pan might look before Serena buys her brownies. So this is one way to do it. You can also do it this way. You can do it that way, or you can do it that way. Either way, it's half full. So go ahead and draw your model now. All right, it says use a different color to show the part Serena buys. Serena wants to buy 3/4 of half a pan. So she wants to buy 3/4 of this. So I need to divide this into 3/4. And I'm going to do that while you're watching live. And I'm going to use dashed lines. So that's half. And here's 1/4. Now, I'm also sectioning what wasn't purchased because remember we have to find the whole. So I want to make sure I just draw those lines anyway since I'm already there. If Serena wants to buy 3/4 of half, she wants to buy 1, 2, 3 of the 4. So I'm going to do this. And I'm going to show where it's cut. So that's 3/4, and that's half. So she has half a brownie pan for sale, and she only wants to buy 3/4 of that. So she's buying these 3 pieces out of the 4 that's left. Let's go to the next problem. What fraction of a whole pan of brownies does Serena buy? How much does she pay? And write a number sentence using of to show your thinking. Go ahead and copy down the model if you haven't already.